In today's lesson, we're going to talk about triangles. So Chapter 5, Section 1 is really all about official and formal terms for triangles and some theorems that maybe you've utilized in the past, but you didn't really know that they were actual theorems. So to start, obviously a triangle, we know it's a three-sided polygon. It's a figure formed by three segments joining three non-collinear points. So as you can see, there's 3 points here. We have point A, point B, and point C. Point A, point B, and point C are called our vertices, which is plural for the word vertex, okay? So what happens is we have these line segments, right? We have line segment AC, and basically here, it's one of the sides of our triangle. We have line segment AB over here, and it's the other side of the triangle. And we have line segment BC down here, which is our third side of the triangle. So really the side of any polygon, including triangle, it's a line segment. And those line segments will touch at a common point called the vertices. And so again, that's where we get, AC and AB meet at point A. If I'm talking about line AB and BC, it meets at this vertices point B, and the other two lines meet at C. So the segments that form the sides, we call they're line segments because they have a start and a stop, and they have a specific length. Okay, so when we have our triangle, we name our triangle based on the vertices. Okay, so since there's 3 vertices here, A, B, and C, this is triangle A, B, and C. We name all the vertices. So if this was like a pentagon that has 5 vertices, it would be pentagon, and I would list the 5 vertices of it. Again, we list the vertices as A, B, and C. We list the sides, and we list the angles, okay? And so again here, angle A, angle B, and angle C would refer to angle A right here. Angle B would be over here, and angle C. So every triangle is going to have 3 vertices, 3 sides, and 3 angles. Now, when I ask you to classify the triangle, a lot of times we ask you to do that. If I ask you to classify it by sides, I'm talking about by side lengths. So when a triangle happens to have 3 sides, none of which are the same, so all different side lengths, right? Then it's a scalene triangle. So for example, in the scalene triangle here at the bottom, this side here might be 3 meters, this side here might be 4 meters, and this side here might have a length of 5 meters. If I showed you in like tick marks, maybe this would have 1 tick mark, 2 tick marks, and 3 tick marks to indicate that none of these are equal to each other. An isosceles triangle is a triangle that has at least 2 sides that are the same length. And the at least is important. We almost always, when you see a triangle that's referred to as isosceles, it has exactly 2 equal sides. But the definition, in fact, says that it has at least. So something that has 3 equal sides could also be called an isosceles triangle, even though it's not super common. Okay, so again, I might identify an isosceles triangle by telling you that this side is 5 meters, and this one is 5 meters, and this is 3 meters. So you recognize that 2 sides have the same length. Or again, we might show you in tick marks. Because these have 1 and 1, I know those are the 2 segments that are equal. And then lastly, an equilateral triangle, all sides have equal lengths. And so again, I might show you that by just showing you that every segment in this triangle is 2 tick marks, which means they're all equal to each other. Or I might not use tick marks, and I might just tell you that, give you the measurements of each side, and you realize, oh wow, all 3 sides are the same. So this equilateral triangle means all sides are equal. Notice equi meaning equal, lateral meaning sides. Now, again, an equilateral triangle has 3 equal sides, which means it's also isosceles. But the more specific name, the better name we would want you to name it is equilateral. Now, we don't always label by sides. Sometimes we classify a triangle by the measure of its angles. And so how this works, it's very specific. I do it a little bit different than this. I look at a triangle, and I look at its largest angle. So let's go down here to the acute triangle. Let's say this is 30 and this is 65, and this would be 85. Okay, and so I would say, well, what kind of triangle is that? What I would ask you to do is to look at the largest angle in the group. And the largest angle is 85 degrees. Well, 85 degrees is an acute angle. And that means that this is an acute triangle. Okay, again, we go to our obtuse triangle here. Okay, and if I have an obtuse triangle, this might be 110, this might be 40, and this might be 30. And so when I'm labeling this triangle, I'm going to look at the triangle and I'm going to identify the largest angle in the triangle. The largest angle in this triangle is 110 degrees, which is obtuse. And that means this is an obtuse triangle. So in an obtuse triangle, one angle is going to be greater than 90. Okay. When I go to a right triangle, okay, again, an example of a right triangle is right here. This might be a 40-degree angle, this might be a 50-degree, and then, of course, the right angle, which is 90 degrees. And so if I'm labeling it, as soon as I see this little square, I know this is a right triangle. But following the same pattern that I did for the other ones, I always look for the largest angle. And yes, the right angle is the largest angle, and since the largest angle is a right angle, then this is a right triangle. And again, a right triangle has one angle that's equal to 90 degrees. And then there's this really specific triangle called an equiangular triangle. Again, equi meaning equal, angular meaning angles, and so it means equal angles. That means that all three angles in an equiangular triangle are equal. Now, we're going to talk about it in the next slide, but all three angles add up to 180 degrees. So if all three are the same, that means that each of these angles is 60 degrees, and that's how it is. Every equiangular triangle has three 60-degree angles in it. And so all angles equal 60 degrees. Okay, so if you notice, 60, 60, and 60 are all acute angles. So an equiangular triangle is also an acute triangle. But again, the best name for it would be equiangular. Now, sometimes we're going to ask you, for example, to label a triangle not only by its sides, but also by its angles, both, right? So yes, you need to know the vocab words that go with sides, scalene, isosceles, and equilateral. And then you also want to know what goes with angles, acute, obtuse, right, or equiangular. But maybe we give you a triangle that is, for example, a scalene acute triangle, or maybe an isosceles right triangle. And so, yeah, you would kind of use both together. A lot of you guys, when I ask you in class, I'll say, hey, what is the sum of the interior angles of a triangle? And a lot of you will tell me 180 degrees because you've learned that throughout your time in middle school. And you're right, it is 180 degrees. So when we talk about the interior angles, first of all, the interior of the triangle is the inside. And the interior angles would be, for example, angle 1 or angle A, right? This angle here. Here's a second angle, and here's a third angle. I use different numbers of tick marks because I don't know if they're congruent or not. And so I know that those three angles, angle A plus angle B plus angle C, has to equal 180 degrees because there's a theorem that tells me that. The triangle sum theorem tells you that the measure of the interior angles is 180 degrees. So should we be doing a proof in this class, and part of the proof is you figuring out the interior angles, now you know that you're going to have to refer back to this theorem that tells you that the angles add up to 180 degrees. So how do we solve problems with it? Well, imagine if I tell you that angle A is 40 degrees and I tell you that angle B is 70 degrees and I ask you what is the measure of angle C, right? So you know angle A plus angle B plus angle C, I'll just call it C, right, is 180 degrees. 110 plus angle C equals 180. And if I subtract 110 from both sides, I get that C equals 70. And so this is how I can algebraically solve for a missing angle. Now, one thing you probably, I don't know if you talked about too much when you were in middle school prior to this class, was about exterior angles. So let's talk about what that could be. We know that in this triangle, we have three interior angles. We've got angle A, angle B, and angle C. What we're not really talking about too often is exterior angles. So what happens is if I take the side of my triangle, like AB, or AC rather, and I extend it out further, it suddenly creates this extra angle here with side CB, angle 1. Well, this is known as an exterior angle. And exterior angles have their own theorems that go with them. The one theorem we're going to talk about today is that the value of angle 1, this exterior theorem, equals the sum of the measures of the two remote interior angles. So we know there's three angles inside. There's A, B, and C. The two remote, it further clarifies and says they're non-adjacent. So which angle is adjacent to angle 1? Well, that's going to be angle C here. If you notice, angle C is adjacent to angle 1. And so that's the adjacent angle, which makes these two the remote angles. And so basically angle 1 equals the sum of whatever angle A equals plus angle B. So again, it's a great theorem and it's very helpful. If I come in and give you a problem and I tell you that angle A is 50 and angle B is 100, let's say, right? You know that angle 1 is 150 degrees because it's 100 plus 50 equals 150. What's also interesting, and we'll learn this down the road, is that angle 1 and angle C form a linear pair. So if angle 1 is 50, angle C is going to be 30. And that's kind of another cool thing, and we'll learn a little bit more about that in the future. So what if they give me, the exterior angle? What if they say angle 1 is 120 degrees and angle A is 70, right? Well, then you know what angle B is, because you know that, again, angle 1 equals A plus B. So 120 equals 70 plus B. And if I subtract 70 from both sides, I know that B is going to equal 50. So again, I can find the missing piece depending on my, what I've been given. So now, again, here's a corollary. This is the first time we're actually dealing with a corollary in math in our theorems, and so it's kind of interesting. So when normally you learn about a theorem, and then sometimes after you learn a theorem, they'll give you a corollary to the theorem. And what the corollary means, it's kind of like a statement that follows it. It can be easily proven from the one that came before it. So if I give you a theorem and then maybe there's a shortcut that I can utilize because of the prior theorem, we call it a corollary. And in this one, we're going to talk about a corollary to the triangle sum theorem. Remember, the triangle sum theorem says that angle A plus angle B plus angle C is equal to 180 degrees. Well, this corollary says that the acute angles of a right triangle are complementary or have a sum of 90. So when would that help and why would I want to do that? Well, let's think about this problem here. Let's say this was 45 and let's say this was angle B. I don't know what it is, okay? If I was to solve this using the original triangle sum theorem, just the original, I would do, okay, angle A is 45, angle B is unknown, angle C is 90, and it all equals 180. I would combine my like terms over here on the left, and I would solve for B, which would be 45 degrees. And that would be my answer, and I don't even need to use the corollary. However, notice that I'm using bigger numbers like 180 and 135. Well, what the corollary tells me is I already know that angle C is 90, right? So the corollary tells me that angle A plus angle B equals the other 90, because 90 plus 90 is 180, right? So instead of setting it up with 3 terms on the left equaling 180, I could just do 45 plus B equals 90, and so B equals 45. Notice I still get 45, but the math is easier because I'm not going all the way to 180. I'm using smaller numbers. Instead of adding 2 terms, I'm only 3 terms, I'm only adding 2. So again, this is just specific to right triangles, and it's a corollary, so it's a little bit of a shortcut. If you forget this corollary, it's no big deal because you can just use the original triangle sum theorem. But again, it's just not a bad thing to use to make your numbers a little simpler. And then now we're just going to get to a bunch of problems that we need to solve. So in this problem, or in these problems, they want us to state whether the triangle with these 2 given angles is acute, right, or obtuse. So all of these, first of all, are angle measures, so they really should be stated in degrees. That would make it a little bit more clear. But basically, I have to figure out if it's acute, right, or obtuse. Well, to know that, I have to know what all 3 angles are. So each one of these is going to require some work to figure out what the missing angle is. So for A, I know that angle 1 plus angle 2 plus angle 3, whatever that is, has to add up to 180 degrees. So 98 plus x is 180, and when I subtract 98 from both sides, I get 82 degrees. So my third angle is 82. Now I'm going to look at all 3 of the angles and select the larger angle. Well, that's the 82. And since 82 is acute, it's an acute angle, then this must be an acute triangle. And that's how we do the math here. So let's do B. So for B, I start with 47 plus 43 plus some unknown angle equals 180 degrees. When I add this up, I get 90 plus x is 180. And when I subtract 90 from both sides, I get that the missing third angle is 90 degrees. Again, I look at my 3 angles and I identify the larger one. It's 90 degrees. That's a right angle, which means this is a right triangle. So yes, there's acute angles here, but again, to decide the name, the triangle by angles, I have to find the largest angle, and it's based on the size of that angle. So then I keep going, I go to C, I have 80 plus 75 plus x equals 180. 155 plus x is 180, and when I subtract 155 from both sides, I get 25. So my third angle is 25 degrees. I'm going to identify the largest angle in the group, which is 80 degrees, and 80 is an acute angle. So this is an acute triangle. Again, I'll keep going. I'll go to D here. And in D, I have 33 plus 33 plus x is 180. 66 plus x is 180. X is, oh, no, not that. X is going to be 114 degrees. So my third side is my third angle rather, sorry, is 114 degrees. Again, I identify the larger one. 114 is an obtuse angle, and so therefore this is an obtuse triangle. And then I'm going to go to my very last one, E, and I get 24 plus 66 plus x is 180. This is going to be 90 plus x is 180, and if I subtract 90, I get x is 90. Again, the largest angle is the 90-degree angle. That's a right angle, so this is a right triangle. So this is how you solve this, and this is the work that I would expect not only in the homework, but also on your assessments. Okay, so now we're here doing example 2. I'm going to look here, and I'm going to start utilizing my resources of things I've also learned in the past, not just in this chapter. So when I go to A, they want me to find the measure of angle A. So first of all, again, always know what they want you to find. They're looking for this angle here. What is the measure of that angle? So I start by noticing that I have two triangles, and I've got this one triangle over here on the left where I've already been given two of the three angles. So I'm going to try to figure out the missing angle there. I know that the two angles I currently have, right? I'll even give it a name, right? You can, kind of give yourself little variables. Let's say this is X. I know that 80 plus 50 plus X has to equal 180 degrees. I've got 130 plus X is 180, and therefore I know that X must be 50. So this angle here, this angle X that I labeled for myself, is a 50-degree angle. So I got that angle. Now I have to figure out, well, how can I carry this over into the other triangle? Well, remember that you learned that these two angles here are vertical angles. So if the one on the left is 50, this is also 50. And so now angle A is going to be easier to find. I know that angle A plus 50 plus the other 50 up here is going to equal 180 degrees. So A plus 100 is 180. And if I subtract 100 from both sides, I'm going to get that angle A is 80 degrees. So it's 80 degrees in problem A. When I go to B, I'm going to kind of do the same thing. I'm going to find the triangle that has two angles already in it, right? I've got these two. So it's going to make the third angle easy to find. I know, again, that this third angle, I'll call it X, right? 60 plus 40 plus X has to be 180. So 100 plus X is 180, and X is 80. So I know this angle here has to be 80 degrees. I also see that there's a tick mark here, a congruence mark, that matches this one. And what that's telling me is that those two angles are congruent to each other. So this one is also 80. So lastly, angle A plus 40 plus 80, again, has to add up to 180. A plus 120 is 180. So angle A must be 60 degrees. And so again here, I have my answer for this one. And then I go to C, and the same thing. I'm going to quickly look at the triangle that has two of the three angles, because that makes it easier, right? So I'm like, okay, 30 plus 110, and I'll call this angle X, plus X has to add up to 180. 140 plus X is 180, and if I subtract 140 from both sides, I get 40. So I know that this missing angle here is 40 degrees. Once I know that that's 40, I notice the congruent mark on this side, so I know this on this angle, so this has to also be 40. And now I'm ready to solve for angle A. I know that angle A plus 40 plus 30 has to be 180, so A plus 70 is 180, which means A has to be 110 degrees. So 110 is the answer for C. Okay? And our last slide goes into the remote angles, right? The exterior angles and the remote interior. So let's look at this one, and we start out, they're still looking for angle A. It's still the question they're wanting me to answer. And so they're like, okay, what did they give me? They gave me one interior angle of 80, and they gave me one exterior angle of 120 degrees. Well, remember that the exterior is going to equal the sum of the 80 plus angle A, right? The two remote interior. Well, the exterior angle is 120 degrees. So if I can just subtract 80 from both sides, I know that angle A must be 40 degrees. And again, think about that. 80 plus 40 is 120, which is exactly what the theorem says. So angle A equals 40 degrees. Now, when I get to this bottom one, I got to be careful with what angles they're referring to, because they didn't do it in the drawing. They told me in the description. So we're talking about triangle EFG. That means we're talking about this triangle here, okay? And they say that the measure of angle G is 100 degrees. So right here, I know this is 100 degrees. Then they say the measure of angle FEH. Well, if I start at F, I go down to E, and I go over here to H, what they're talking about is this angle. So they're referring to this exterior angle. And they tell me that FEH is 3 times the measure of angle F. So let's call angle F, F, okay? So this is 3F. And so once I do it like that and I give things a variable, all of a sudden I think it might make more sense, right? And I could even give it I should call it lowercase f. It's probably the more proper way to do it, right? But bottom line is I know that the exterior, 3F, is going to equal the sum of the 2 remote interiors, which is F plus 100. So 3F equals F plus 100, which makes sense. So now I'm ready to do my math, right? So I'm going to subtract F from both sides, and I get 2F equals 100. And if I divide both sides by 2, I'm going to get that F equals 50. So it says find the measure of angle F. Well, that's 50 degrees. So let me come back over here and see if it actually works, right? So if this is 50 degrees, then angle F plus angle G is 150. And that's what the exterior angle should equal. And notice 3 times 50 is 150. And so it works. So again, just make sure that you set it up correctly, that you're identifying the correct angles, and just remember your theorems. And this is going to be pretty easy.